We now begin our study of static equilibrium. And to get into this, let's look at something very simple, a block on a table. Here's a block on a table. Now this block is pushing down on the table, and the table is pushing up on the block. And these forces have to be equal and opposite. How do I know that? If this block was pushing greater on the table, it would crash through the table. If the table was pushing greater on the block would be bouncing in the air. They are equal and opposite. It looks like this. Here's our block on the table. Its weight acts down, and there's the normal reaction force of the table up, Newton's third law. And the force up equals the force down. This block is not moving. And we can say, if a body is at rest, it is in a state of static equilibrium. In order for something to be in static equilibrium, there are two conditions, and we'll look at the first one right now. It's often called translational equilibrium. Now this word translational, one of the uses in English means moving from one point to another. If I'm standing at one point in a room and I move to another point in that room, I can say, I was translated. You may have never heard of that before. I encourage you to look it up in the dictionary, and you'll find that that is one of the meanings of the word translate. So in order for something to have translational equilibrium, it means it is not moving from one point to another. Here's how we write that down mathematically. So here's how we write it. We can say the sum of every x component equals 0. Now that symbol there is the Greek sigma, capital S, meaning the sum of in math and in physics. And of course the sum of all the y components is 0. Now I find that it's a little bit easier to write it in a different way. It makes the equations a bit easier. The sum of every component to the left is the sum of every component to the right. The sum of the forces up equal the sum of the forces down. That makes it easy to set up equations, as you'll see. In order to understand this, we'll look at a couple of problems, and then it'll become clear. I know right now you're thinking, what exactly does this mean? So let's move on to the next clip and look at a sample problem, and then you'll have that aha, I get it experience.